Hey folks, welcome back to another video. Today we're looking at question 1404, number of steps to reduce a number and binary representation to 1. The way we'll be solving this problem is by looking at the rightmost digit and try to compute based on whether it's 0 or 1, how many steps are required, and make our way back to the leftmost digit. So let's get started. There are a couple of things that we care about. We need to keep track of the number of steps, right? And because we'll be adding 1 in a few cases, basically when it's odd, you need to also keep a track of the carry, like how much we'll be carrying over. And we'll initially start that with 0 since we're not going to carry over anything, right? So since we are starting all the way from the right, we'll do int I equals s dot length minus 1, since the indexing starts from 0, and we'll go all the way up till 1, like the second index, which is like 1 in this case, but not 0, because we know it's guaranteed in the question that it will reach 1 in all the cases. So we don't have to take the last number remaining, because it will be 1, and then you keep decrementing it. Awesome. Once we have that, let's get the current digit. So int current would be equal to s dot character at I, and then since it'll be in binary 0 or 1, we just subtract 0 from it. So to get the integer value, we could also use this built-in method, which is kind of like character dot get numerical value, numeric value I think it's called, but either one is fine, but I guess in production level code this is definitely better. Right, we have the current digit, but now we need to check what is the value that will give us once we have the carry. So we have current, and then we have carry value with us, right? So if the current and the carry, if this is equal to 1, right, if it is equal to 1, there are 2 steps that you need to do. You need to add 1 to it, and you need to divide it yet again. So because when you add 1 to it, it becomes odd, and once you make it once you add 1 to it, it becomes even, and then you need to divide it. So anytime you encounter a digit that has 1, there are actually like 2 steps that you're taking, right? So you need to increment it by 2, and once you carry over, since you're adding 1, the carry is reset to 1. Since you're adding 1, so 1 excuse me, 1 plus 1 becomes 2, but in binary it becomes 1 becomes 1 0 when you add 1 to it, because it's represented in binary. That's the reason why the carry is reset to 1. In the other case, where it's equal to 0, or it's equal to 2, you just divide it, right? So the number of steps that you would be incrementing is just 1, right? And in the end, once you're done with the for loop, you just need to return the number of steps, and if there's any carry, you need to add that as well, just as a leftover. Awesome. That's basically what the problem is. Let's try running it and compiling it. Yeah, the first few test cases are okay. Everything else is okay as well. Awesome. So let's talk about the space and time complexity of the entire solution. The time complexity of the entire solution is of n. Since we have to iterate through every single character in the string, the space complexity is of 1, since we're using only constant space to keep a track of the result that we care about. Awesome. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I'd really appreciate that. It keeps me motivated to make more videos. Thanks so much, and I'll see you folks soon. Peace.